Okay, we have come to the last question, 14. So question 14 asks us to find a probability. Probability of obtaining exactly one head when flipping 7 coins. Okay, let's see. So let's recall probability of any event. Right. Let's recall the definition. As a fraction, is a desired outcomes. Actually, we should see cardinality of the desired outcomes divided by the cardinality of all possible outcomes. Right? Again, it's part of something over whole thing. So now let's see, we have 7 coins. Let's see, we have 1, 2, 3, 4, 5, 6, 7. And when we flip each coin, we could get head or tail. Head or tail for each one of them, right? For each one of them, the possible outcomes. So I'm listing the possible outcomes now. So I have 2 choices. We have 2 choices for this, 2 choices for this, 2 choices. So each one we have 2 choices. By counting principle, we multiply them. We multiply them. While we multiply them, you can think by tree, right? Because first one, we could have head, we could have tail. The second one, if the first one is a head, the second one could have a head and tail. If the first one is a tail, we also could have a head and tail. You see the second one becomes 4. Right? So 2 times 2, so on and so forth. That's why we multiply them. So we get 2 raised by 7. So when we multiply, we get 2 raised by 7. That's 2 times 2 raised by 6. That's 2 times 2 times 2 raised by 5. 2 times 2, that's 4. 2 raised by 5 is 32. So 4 times 32, that's 128. So we know the denominator is 128. Now, desired outcomes, right? Desired outcomes, we could, the first one, like, could be, so we're looking for head, right? When we maybe, so exactly one. So when we flip this all 7 coins, we could have the first one only edge, only head, right? Then the rest is the tail, tail, tail. Or we could have the second one to be head, and all others are tail. Or we could have the third one head, the others are tail. So you will keep listing this. So the first one could be a head, the fourth one could be a head, and then this one could be head, then the last one could be head. So how many of them? We could have H, T, 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 T. This is the one desired outcome, this is second desired outcome. So we add them together, this is 7. So here we do not multiply, right? Because this is one desired outcome. So has one head, which is the first one to be a head. And the second one is a desired outcome, which is the second one to be a head. So third one to be a head, fourth one to be a head. So that's why we add them. So we add them, we'll get a 7. So it's a 7 out of 128. You don't really need to convert into decimals. You keep as a fraction, which is perfect. Okay, that's the last question. And I see you in class.